Okay, here we have the notes for section 1, the real numbers. So the first part here is just a bunch of definitions. So you got representing real numbers. So real numbers, any number that can be written as a decimal. Now those numbers can be broken down into smaller groups. So you have the natural numbers, which are the numbers 1, 2, 3. These are sometimes referred to as the counting numbers. You have the whole numbers, which adds 0 to the group above it, and then you have the integers, which adds the negatives to the group above that. So the natural numbers are the smallest group. When you add 0, you get the whole numbers. When you add the negatives, you get the integers. Now, just a note here, these symbols, the braces, are used to enclose the elements or the objects in a set. A rational number is any number that can be written as a quotient, a over b of two integers. So what this means that a over b, given that a and b are integers and b not 0, because if b is 0, this thing is undefined. So a rational number, the other way to think about a rational number, in addition to being written as a fraction, is if it's a decimal, it either terminates, so it ends, like 0.25, 0.5, 0.6, or is infinitely repeating, so 0.3 repeating, 0.1 repeating, things like that. Now all of those decimals are fractions. 0.25 is 1/4, 0.5 is 1/2, 0.6 is 6/10 or 3/5. Infinitely repeating, 0.3 is 1/3, 0.1 is 1/9. So they are still technically fractions, but you can also write them as decimals. You have an irrational number if it's not rational, meaning that if it's a decimal, it does not repeat and does not end, so infinitely non-repeating. The most common one of these is pi. The letter E is also one, but those are some examples. All right, so example 1 down there says determine the decimal form of 1/6, 55/27, and 1/17. So to convert a fraction to decimal, remember the fraction bar is a division problem, so 1/16 is 1 divided by 16. So that is 0.0625. And you notice this terminates. 55 divided by 27 is 2.037037. So there, if you notice, there's my repeat. The 037 just keeps repeating. And the last one, 1 divided by 17, is 0.05882352941. Now if you notice, this doesn't end or appear to repeat. Now this sometimes happens. This is definitely a rational number because it's a fraction, but the repeat distance or the terminating distance is so far out that your calculator may not necessarily be able to display it. All right, so on to the next page. All right, so see if I can fold down, there we go. Oops. The real numbers and the points of a line can be matched 1 to 1 to form a real number line. So typically you start with a horizontal line with the real, and match the real number 0 with the point O, the origin. Positive numbers go to the right, negative numbers go to the left. So this essentially is just referring to drawing your standard number line. So number line, so there's the origin, but positive numbers going right, negative numbers going left. Order and interval notation. So the first part just here just refers to numbers are ordered, meaning some numbers are greater than or less than other ones. And then your inequality symbols here. So these are your inequalities, the greater than sign, the less than sign, less than or equal to, greater than or equal to. Now, less than signs point left, so that's why these two are the less than signs. So numbers can have one of three relationships. The first number can be less than the second. They can be equal or greater. Inequalities can be used to specify intervals of real numbers, so sections that are valid. All right, so example 2 here, interpret the meaning of and graph the interval of real numbers for the inequality. So this is numbers less than 3, and if you were to graph it, so there's 3, it's an open circle because it is a less than sign, no bar, and less than would be going that direction. So here you have the numbers greater than -1 and less than or equal to 4. And on the number line, so there's -1, there's 4, open circle at -1 because there is no equal bar, closed circle at 4, and connect. These have to be between. All right, example 3, write an inequality based on the description and draw the graph. So real numbers between -4 and -0.5. So -4 less than x less than -0.5. Notice no equal bars because it say or equal to -4 or -5. Then draw the graph, -4, -0.5. Both open circles because those are regular less than signs, and connect the dots. Real numbers greater than or equal to 0. So x greater than or equal to 0 would be your equation. And on a number line, 0, close dot, going to the right, greater than. So intervals can have more than one type. They can be closed if it contains its endpoint, or open if it does not contain its endpoint. So this one up here, we're at double open circles. That's referred to as an open interval. If I had another closed dot somewhere on this one, that would be a closed interval. They give you some symbols down here. So you have what's referred to as interval notation, closed, open. So you can have half open, where you have one closed circle and one open circle. We'll talk about the interval notation on the next page. And then you have the graphs over here, using brackets and parentheses instead of closed circles and open circles. All right. So these are your types of unbounded intervals, meaning that they do not have two endpoints. So you have from a to infinity, so that's x is greater than or equal to a, so the graph runs all the way to the right. You have this one, which is open, because it has an open circle here going all the way to the right, and then you have the less than versions going that way. All right, so example 4, convert interval notation to inequality or vice versa, then state whether it's bounded or unbounded, open or closed. So here we go. So this is interval notation. So in interval notation, a bracket is the same thing as includes the or equal to bar. Parentheses like down here do not. So this is -x less than equal x less than equal 3. So this is bounded and closed because it has two endpoints and those are included, so it is a closed value. This one would be negative infinity less than x less than -1. Sometimes you'll see this. Normally you would just write it like this because it means the same thing. So this is unbounded and open because it does not include the endpoint. And it doesn't have two, there's not a number here, so it's not bounded. The last one, so this wants you to go backwards. So -2, 3 is going to be brackets in either place because they both have the or equal to bar. So this one is bounded. You have two numbers and closed. All right, basic properties of algebra. So just a couple definitions. A variable is a letter or symbol that represents an unspecified real number. A constant is a letter or symbol that represents a specified real number. And then an algebraic expression is a combination of those involving some operations, addition, subtraction, multiplication, division, powers, and roots. And then you have a whole bunch of properties of algebra, which I'm not going to spend a whole lot of time on because you can read them just as well as I can read them to you. All right, so if we just do example 5, I write the expanded form. So this is asking you to distribute. So the x is going to multiply both values. So that's ax plus 2x. That's what you're looking at. Factored form. So factor means pull out the common terms. So in this case, both these terms share a y. So the y comes out front. And you have 3 minus b. So here's your factored form. Okay, and moving along. Now we have exponents. So integer exponents. So just a reminder of what an exponent does. Exponent tells you how many times you're multiplying a value together. So example 6, identify the base. So the base is the thing being raised to the power. So for this problem, the base is -3. So I'm going to multiply 5 -3's together. On the second one, the base is just 3. It's 3 to the 5th. And then at the end, you make the answer negative. So be careful with where your parentheses lie because it will potentially change your answer, especially if you have an even power. Properties of exponents. So you have the multiplication property, where you multiply two values, you add their exponents. Quotient property, you divide two values, you subtract the exponents. This is the zero property. Anything to the 0th power is 1. Negative exponents are reciprocals. This is power rule. Powers can distribute. That's a power of a power. You multiply the exponents, and the same thing here as number 5, where you can distribute the exponent to a fraction. Now, the one time you cannot distribute an exponent is if you see an addition or subtraction sign in between your parentheses, or in between your values inside parentheses. In that case, it does not distribute. All right, example 7, simplify the following. So this is multiplication, so we'll start with our numbers. 2 times 5, that's 10. So for our a's, since we're multiplying, we add their exponents, so a to the first and a squared, that's a cubed. And for b's, b to the third, b to the fifth, 3 plus 5 is 8. Now in this one, my first step is I'm going to take care of these negative exponents. Now terms with negative exponents, so this v and that u will cross the fraction bar. So that u squared is going to stay on top. This v is going to move, but that u is going to come up, so you have a u squared u to the first. And on the bottom, you have the v cubed, that one, and then the v squared comes down to join it. Now these can be combined, you're multiplying, so you add exponents, u cubed, v to the fifth. All right, so the last one here, we'll distribute that exponent first, so that's x to the negative sixth over 2 to the negative 3. So it's a negative 6 here because 2 times negative 3 is negative 6. Now we'll take care of our negative exponents, so they cross the fraction bar, so it ends up like this, and then 2 cubed is 8. Simplify your number at the end. All right, and now we have scientific notation. So any positive number can be written in scientific notation, where you get in the form c times 10 to the m, where c is greater than or equal to 1 but less than 10. So you can't have 10 times 10 squared. This number has to be less than 10, so 9.9 repeating is the largest value, and m is some integer. If you have a positive exponent, indicates that moving the decimal point to the right produces the decimal form. Negative exponent means you need to move the decimal place to the left. So convert the following. So this first one is going to ask us to go back to the decimal form, and the second one's going to ask us to find the scientific notation. So 10 to the 8th means I need to move the decimal place 8 places to the right. So 2, 1, 2, 3, and now I need to fill in zeros. 4, 5, 6, 7, 8. So that is the actual value, 237,500,000. Now this one is going to be 3.49 times 10. Now to figure out what my exponent is, so I move the decimal place until I have a number between 1 and 10 in front. So it's 1, 2, 3, 4, 5, 6, 7 times. So a negative 7 would go there, because I would need to move the decimal place 7 spaces left in order to get back to my actual number. 1, 2, 3, 4, 5, 6, 7. Just making sure. All right, example 9. Wants you to convert this to scientific notation first, then do the operations. So that first one is 3.6 times 10 to the, let's see here, 1, 2, 3, 4, 5, fifth. The second one is 4.5 times 10 to the 3, 6, 9th. Remember, the exponents are just how many times you move the decimal. And the bottom one is 1.8 times 10 to the 4th. So when you work it out in second notation, you can work the numbers out. 3.6 times 4.5 times 1.8. 3.6 times 4.5 divided by 1.8. So that's 9 for my numbers. And then for the exponents, I can use my exponent rules. These two are being multiplied. So 5 plus 9 is 14. And so dividing by the 4th power, I would subtract that. So 14 minus 4 is 10. So that would be my answer. I believe that brings us to the end of the section.